Imagine a world where a computer can listen to a forest and instantly identify which birds are singing, or decode the clicks of a dolphin in the deep sea. That's the future of bioacoustics, and it's being powered by a breakthrough called Perch 2. Let's dive into how this AI model is rewriting the rules of listening to the natural world. So what's Perch 2? Think of it as a supercharged version of its predecessor, Perch. But this isn't just about birds anymore. While earlier models focused mainly on avian sounds, Perch 2 is a universal listener, capable of recognizing everything from frog croaks to whale songs. And it's not just good at this, it's exceptionally good. In tests, it's outperformed specialized models trained only on marine data. How? Let's break it down. At its core, Perch 2 uses a technique called self-distillation. Here's how it works. Imagine a student who reviews their own old exams to improve. The model doesn't just memorize sounds, it learns to understand them. By comparing its predictions to its own previous answers, it refines its knowledge, like a detective piecing together clues. Then there's source prediction, a clever trick where the model guesses where a sound came from. Is it a forest? An ocean? A city? This helps it contextualize what it's hearing, making it smarter about distinguishing between similar sounds. And here's the cherry on top, mix-up. This technique blends audio clips, like mixing a bird's song with a whale's call, forcing the model to spot patterns in chaos. It's like training a detective to find a needle in a haystack by mixing in random objects. What sets Perch 2 apart is its efficiency. It's built on a smaller, faster neural network called Efficient NetB3, which means it can process sounds quickly without needing massive computing power. This makes it practical for real-world use, like monitoring wildlife in remote areas or tracking environmental changes. But the real magic? It doesn't need as much labeled data as other models. Most AI relies on thousands of carefully labeled examples, but Perch 2 learns from raw, unlabeled sounds. It's like teaching a kid to recognize animals by exposing them to thousands of pictures without saying, "This is a dog." Perch 2 isn't just a tool, it's a glimpse into the future of bioacoustics. By making AI more versatile, efficient, and adaptable, it opens doors to applications we're only beginning to imagine. From protecting endangered species to understanding how climate change affects animal communication, this model is helping us listen to a world we've only just started to hear. Now let's zoom in on marine bioacoustics, the ocean's noisy, complex symphony. The problem? Waves, ships, and thousands of species all make sounds, some similar, some totally unique. Classifying them? It's like trying to find a needle in a haystack, but with AI, we've got a better magnifying glass. Enter transfer learning, a clever AI trick where a model learns from one task and applies that knowledge to another. Think of it like learning Spanish to help you pick up Italian faster. But here's the twist, the foundation model you start with matters a lot. And Perch 2. It's the ultimate student. Let's talk numbers. In a key test, Perch 2 crushed a rival model. When using raw data, called logits, it only got about 61% right. But when it used embeddings, which are like richer, more detailed sound, fingerprints, it nailed 95% of the classifications. That's a huge leap, like upgrading from a flip phone to a smart device. Why does that matter? Embeddings act like a universal language for sounds. Even if a model wasn't trained on a specific whale call, it can still spot patterns and adapt. In tests, Perch 2 outperformed specialized whale models. Imagine a generalist solving a puzzle better than an expert. The proof is in the data. Across datasets like NOAA and ReefSet, Perch 2 consistently blew other models out of the water. But it's not just about being fast, it's about being smart. With fewer examples, it learns faster, making it a goldmine for researchers tracking endangered species or studying ocean health. So what's the big takeaway? Pre-trained models like Perch 2 aren't just tools, they're springboards. They let scientists tackle complex problems with less effort, opening doors to discoveries we've only dreamed of. And the best part? This is just the beginning. Imagine AI analyzing ocean sounds in real time to protect marine life, or a global network of sensors listening to the planet's heartbeat. Perch 2 is paving the way. Thanks for watching. Want to dive deeper into AI's role in science? Hit subscribe and let me know what you'd love to explore next. Until next time, keep listening to the world around you.